The next part of the NMR theory that we have to look at is chemical shift. This is with reference to the scale that you'll see in a spectrum in NMR. It goes from 0 to 13, sometimes you'll see a 14, and you'll see peaks at different positions along here, just like you would in any other type of spectra. Now the units here are ppm. So depending on what your hydrogen is attached to, directly attached to, depends where the position of the peaks are. And it's, a lot of it is to do with electronegativity. So if we just cover or recap electronegativity now, again, this is first year stuff. Electronegativity is a tug of war. Tug of war of electrons. In a bond, say we've our carbon and hydrogen. So carbon and hydrogen. When they're bonded, they're sharing one pair of electrons. Now what's happening here though is that there's a wee tug of war going on between the two atoms, and the prize is that pair of electrons. Electronegativity value for carbon is 2.5, hydrogen is 2.1. The strongest man always wins the tug of war, and here carbon's going to win the tug of war. So the pair of electrons, whilst they're still bonded, the pair of electrons pulls towards the carbon a lot more than the hydrogen. Now it doesn't go off completely, it just pulls a wee bit more towards. If we have a situation where we have oxygen and hydrogen, oxygen's 3.5, hydrogen's 2.1. Again, they're sharing a pair of electrons, but oxygen's a lot more powerful than hydrogen. So the pair of electrons are going to be pulled a lot more towards the oxygen than the hydrogen. Not so much up here because they've similar enough electronegativity values, but a lot here. And a third situation is, say we had something like chlorine and hydrogen. The halogens are the most electronegative group in the periodic table. Now off the top of my head, what's chlorine? It's probably going to be somewhere up around 3.8. Hydrogen's still 2.1. So they're fighting over this pair of electrons, and it's going to go towards chlorine. Now, so that was a recap on your electronegativities. So you need to understand that and understand this. On your scale from 0, now I've just put on 10 here. Anything that appears up here is referred to as upfield. Anything that appears down here is referred as downfield. Now, what's upfield? Well, it's anything that's shielded. The less shielding that goes on, the more de-shielded it gets, the more your hydrogens will travel down here. Now, I've written there different functional groups will appear at different positions. So chemical shift is all to do with shielding, and again goes back to the stuff here. When you think about it, electrons that orbit the nucleus plus the proton is in the nucleus can provide a shielding effect from the nucleus from the applied external magnetic field. So you have the internal magnetic field here, you have the external magnetic field here, but the electrons surrounding the nucleus protects it or shields it from the external magnetic field. Now, if you have high electron density, loads of electrons, you need more energy to flip. But if you only have a low electron density, you need less energy to flip. So I've taken these atoms here, and if you just look at it, carbon and hydrogen, because they have similar electronegativity values, they're sharing that pair of electrons quite evenly, so it's shielded. So any hydrogens directly attached to carbon is going to appear along here. Oxygen, we know now, is a lot more electronegative than hydrogen, so it's winning the tug of war, and it's pulling the electrons, that one electron, away from the hydrogen, and it's leaving hydrogen sitting out there on its own, and there is no electron then to protect the nucleus in the middle. So it's less shielded. Now the worst case scenario is when you've got a halogen attached to a hydrogen. Because they're so electronegative, they pull away that electron from your hydrogen, and it's even further de-shielded because chlorine is very electronegative. So that's why different hydrogens in different environments will appear at different positions along the scale. So that's what chemical shift is. Where on the scale your hydrogens appear, and it's all to do with shielding business.